My name is Paweł. I used to like Turbo Pascal, but these days I like Clojure more. I also like classical music. And just so you know, this is a 40-minute talk in 30 minutes, so I won't cover everything from the slides, but I will upload them later to GitHub in case you want to read them later. So let's begin. In 2021, I joined English language iTutoring, a small startup founded 7 years earlier. It was at its humble beginnings operating from a repurposed shipping container in Bristol. Later, it was acquired by Cambridge University Press and Assessment. And we offer products for language learners, such as Write and Improve. We also provide APIs, which are, of course, used primarily by the products, but also by Cambridge directly. And last but not least, we provide annotation services, mainly to power the machine learning models behind the APIs, which brings us to Manatee. So meet Manatee. So in 2021, when I was joining, all 3 other Manatee team members were just leaving. I had just a month-long crossover with the key person. Moreover, inherited a bespoke text editor with annotation features written from scratch in ClojureScript by a previous employee who I have never met. And the editor was the elephant in the room. It's the second elephant in the room today. And then for 6 months, I was learning the code base with a consultant. Later, the team grew to between 3 and 4 permanent members, which brings us to the years covered by this talk. And recently, I moved on to another team to seek new challenges and giving this talk to reflect on our adventures in Manatee because the experience was something special. So the system was capable of doing speech annotation, which is correcting the transcription and then correcting English grammar in it. So the first step, is it actually accurate transcription? Second, is it a proper English? Then we've added text annotation to it for things such as essays written by learners. And that meant different annotation rules and a slightly different data model, and I will show you how it looks in a second. After that, we developed multi-word expressions, which is a peculiar thing. It's an example of multi-word expression is a phrasal verb, so to catch up, for example. So marking those in essays, again, for machine learning. And all of this was fun, but the most fun was adding conversational speech annotation. And why all this? Because annotation data is needed, of course, to train machine learning, to later annotate for us, so we can automatically give feedback to the learner. So here we are doing some text annotation, so we are basically correcting it to make it a proper English, and we are adding words that were missing, removing words that were unnecessary, correcting some, punctuation and stuff, replacing entire words. Here, the last thing we added ain at the end of month to make a mountain and maybe you've noticed that we just had to type the last 3 letters, and the idea is that as you correct things, we don't get rid of the previous word, the previous token. We just mark it as something that needs to be corrected, and we insert the rest, as you type. So it's sort of like tracking changes in Microsoft Word, but on steroids with many custom rules. Okay, so let's start from the data. So on the left, you have the data representation of an annotated script. On the right, you have how it looks on the screen for the user. So we corrected had and visited into visited. So our document is a map. It has a script, which is a vector of tokens. Each token is a map. They have various types, such as a word, a space, or an edit. And in that map, we also have a selection, which is relative to the tokens, which is handy because rather than just having an offset in the entire text, we we go directly to a token, and then we have an offset of character inside that token. The editor is written basically using content editable. So for those who are not familiar, content editable is a thing in HTML that basically gives you some basic editor, but then you have to figure out to customize it. For the state in the editor, we are using Reagent, so quite a classical at this point solution. The app itself is using Reframe, but the editor is just a component. And yeah, we have to override the rules of content editable. So we have a custom DOM event flow. So to support annotation, we have to tame content editable, and to do that, we listen on before input events to tell the browser to stop, to not do anything with that event. We still get events such as key down. So we listen on those, and we convert those events into Clojure maps, as you can see on the screen on the left. And then we use that map as a dispatch value on a multi-method, which is there on the right. For pattern matching in that multi-method, we are using a customized version of new banks matcher combinators library. And so our editor is built in a way that when user executes an action, that action is added to a queue, and that action is a Specter navigator. But if you are not familiar with Specter, don't worry, you can think of them as just functions. And the purpose of those actions is to modify the selection or modify the contents of the script, or both. And an action can be something very easy to figure out what it is, because maybe it's just a button click, right, on a toolbar. So maybe you have a very simple action, so it's obvious what you want to do then. But it can be more tricky if you have something that corresponds to maybe key press, and that can vary depending on the context. So that brings us to the second level of dispatch, when we basically sort of pattern match depending on pressed keys and other contexts. Mostly this is what text has been selected, what's around in the editor of the cursor. And for this, we are using cont path in Specter, which is very similar to cont, but at least conceptually you can think just like Clojure cont. And yeah, we have just pairs of rules, basically conditions and actions, and the rules can grow. The rule set can be quite large, so we sort of modularize it. For example, we have custom like sets of rules for caret selection and multi-char selection, and that forms our rule base in the editor. And how do we render it? Well, each token is rendered as a span element, and we basically render it after each user action. So if you think of React, user action changes the data behind, that triggers the render. And after that, we have to update the selection. And selection has to be fully managed in the editor, because we have to update it for annotation needs. So let's see a quick video. So as I'm typing, when new token is created, the cursor jumps right into the correct place, so the user can just keep typing without worrying about where to put the cursor, obviously. And how do we manage the selection then? Well, to read the selection, we listen on a selection change event in the web browser. Then we calculate absolute offset in the entire document, and we convert it into the token-based map format, which you can see on the right there. And to the opposite thing, to write the selection, we do that in reagents after render. So render doesn't invalidate our selection. We do it after render, and we do the opposite thing. So we go from we calculate the absolute. We go from our map format, and we calculate the absolute numbers. So the opposite of the previous slide. And we find the DOM nodes to which we need to apply the selection. All right, so having the basics of the way, let's talk about Specter. So we hit some problems there. This one is in the ClojureScript. So when cont path that we are using quite a lot is compiled down to a function invocation, because Specter compiles down things for pre-compilation for performance. We hit a limit of 20 function arguments for functions with metadata. And this is really a ClojureScript itself edge case, and we found this reported, and this report was quite useful in figuring out what was going on, because all we could see was the error invalid arity 2020. So thank you, Arne, for reporting that. And the workaround was quite simple, because if you think of cont path just as cont, if you cannot have more than 20 things there, you can just have a macro that basically, if you have more, you add else statement at the end and nest another cont inside. So that's what we did, just a macro as a workaround. And previous issue was on ClojureScript. This is on JVM. Kind of similar thing. So Specter precompiles things differently on different platforms, because they work differently. So it makes sense. But that means that when we are hitting edge cases, we are hitting them differently on different platforms. So here we had one particular large rule set, which was closing over locals, just few locals, but each usage of local was compiled down for performance as a function invocation as each individual argument of function. If you remember, in IFN you can have only 20 positional arguments. Those were positional arguments. So we got that error, and here the solution was very easy. We just split that particular rule set, because if you can imagine, if it used parameters that many times, it was quite large already, so it was a good thing to do anyway. And don't get me wrong, I like Specter. What I'm saying here is just about our usage of Specter. So Specter is great for processing deeply nested data structures. So when you have a vector inside a vector, and then map and a vector, but our data structure was flat. It is just a vector of maps. So that wasn't a good fit, and Specter brings some mental overhead in terms of understanding it. It's almost like a different language. I was thinking during Jeremy's talk, when Jeremy told about SQL as a declarative language, of course. And Specter has that feel, is more declarative than Clojure itself. And imagine if in SQL you can write declarative statement, but for each clause you have to provide your own implementation as a C plugin, for example. So this is how our usage of Specter looked like, just because it's not perfect fit for the domain. So if you have a domain when you can express everything you need just using built-in primitives in Specter, that's great. Ours wasn't. So for our usage, I think Clojure functions would be perfectly sufficient, but this is easy to tell you after the fact. You know, while doing text annotation, we had to understand what was already there, every rule, what what really is it that it's doing, and yeah, having infinite resources and time, it would be probably good to think about changing that to Clojure functions, but it does the job as is. It's just not perfect. Okay, so let's quickly see some debugging tooling. So I just pressed spacebar here, and debugging wrapper of cont path has printed out the exact rule that was executed at that time. And then I selected some tokens and pressed a debugging keystroke to print out the data behind those tokens. So those are quite useful, were quite useful in figuring out where to make the changes, how the data looked like before the changes and after them. All right, so what really has helped was the data structure. So just the script as just a vector of maps is quite good. Maps for tokens is quite good. Also, the selection as a map which is relative to tokens was really great. Also, the things that we get for free from Clojure, so the immutability when processing complex changes is obviously very useful. Also, getting the history for free. Hopefully no one is going to be shocked by this one. Having a good test coverage was really essential in introducing text annotation. So this is where project was in excellent shape. The tests are really simple. They are super quick to run and they are easy to understand. So the input is just the document and of course some action. So a button press or a key pressed. And the output is the updated document after that action. So obviously the domain makes it easy. It helps really, but this advantage has been fully used. And another maybe trivial thing, but when understanding a new code base with custom, macros, some obscure things here and there, it really helps to document them, going, from the simple things to build up our knowledge upwards, and that way we don't have to repeat our understanding of the fleeting ideas, after coming back after the conference, and also it's easy to understand just by building up the knowledge. All right, so the domain was not only excellent for unit testing, but it also was a good fit for property-based testing. So we had a quite obscure bug, difficult to reproduce, when the basic property of annotation wasn't holding. So what is it? It's after you remove all annotation from the script, so after you strip it from all of the markup, it should be the same as the original, as before annotation, except in some cases it wasn't. And the issue was that the selection wasn't the same when doing batched execution of user actions, which is rare, doesn't normally occur, only when there are some performance issues. The selection wasn't handled in the same way. So if you do it in normal way, serially, one after another, you compute the new selection, write it to the browser. Browser notifies you about the new selection. You get the event. You store it, and that sort of normalizes the selection. But of course, doing that in batches meant that selection was all in memory, and unfortunately, it was inconsistent with the other way of doing that. And that seemed to be absolutely impossible to reproduce manually, on developers' laptops. But it was very possible to find out using property-based testing. All right, so we've talked about text annotation enough. Let's go to conversational speech annotation. So first, just a definition: what is speaker diarisation? It is dividing speech into segments. Each of segments correspond to a single speaker, and segments can sometimes overlap if multiple people are speaking simultaneously. And why are we doing this? basically to improve the existing models, both in performing speaker diarisation and in accurately transcribing conversation, because transcribing conversation is with lots of interaction is more tricky. And the goal here is to have conversational features in learning apps for learners, so people can, two students can conversate, get feedback, etc. Also, probably to maybe auto-mark exams in the long feature. And yeah, and just for a note, we have in our current data set we have two speakers, candidate and interlocutor, and later we might need to support a third one. Okay, so I'm definitely not an expert at this, but I can tell you what I know from the MR side. We are using two tools. The first one is to get speaker diarisation, so the segment times basically and who is speaking. So for that we are using Pianot Audio library, and to get the actual transcription we are using Whisper, which I'm sure many people have heard of. And those tools can be tweaked. They can be improved by further training, which is good because, for example, Whisper is not great for learners' English. It smooths out over learners' mistakes, doesn't represent them well. So yeah, obviously that makes sense for the project to do actual annotation, and the tools are called independently of each other, so they are called independently, and then the outputs are combined. And as you will see next, how the data looked like, what we were getting from researchers. So those are CSVs, which obviously are represented as tables. In the first column, we have a speaker. It can be either candidate or interlocutor. Interlocutors are on blue background. Then we have the start time of a token, duration of token, both in seconds, the word that was spoken, and confidence of ML in accuracy. So on the left, we have the happy path. You can see that there is a nice run of candidate speech and interlocutor speech. On the right, it doesn't look as nice because the tokens are duplicated really and interleaved, if you notice so and I in the middle there. And we can't have segments like that. They are just too short and too many. That would be terrible for annotation, and so we have to sort that out. So we have a very simple algorithm. When we add the tokens, we go from right to left, and we try to find the token that's before the token that we are about to add, and obviously it's from the same speaker, and that's how we add the tokens, reshuffle them, as you can see on the diagram. And then after we have the tokens in the right sequence, we just partition the sequence whenever there is a token a speaker change, or whenever there is a long gap, and we just use the mid-list partition between. I think for that is quite handy. And yeah, and after that we just create new segments from each partition. So you can see there are two maps, two segments. So they have duration, they have start time, end time, the speaker, and the transcription vector. And this is very similar to what we had on text annotation. We just have the start time, duration, also confidence. Okay, so let's see a quick demo, but I think I need to switch my sound. Oh, it's already all right.
I don't. You don't? I don't take any medication, but...
So basically the job of the annotator is to listen to the audio and find whenever there might be a problem. Here we have a, excuse me, we have a missing segment when the other person sort of confirmed what he heard. But
I don't take any medication, but I'm thinking that...
Here we have repetition of words which didn't really happen.
Sleeping pills might be an option.
So we are just deleting those repeated words.
Oh, okay. I see that. Can you tell me more about your stress level at work? How much stressful is your work?
Well, I work.
And here is a problem when the same tokens are assigned to both speakers. When at the time when the segments contact, the same tokens were assigned to both of them, and the fix is easy. We just resize it so the software uses only the tokens from the original ML data.
Well, I work long hours, and it's a pretty high-powered job, but I don't particularly feel a lot of stress.
Okay.
Same issue. AHA was set by only one person, but it was assigned to both. So we just shrink one of the segments, and the tokens disappear.
Okay. Can you tell me about the usage of caffeine or other stimulants during nighttime?
Okay, and here we had something different, sorry. At the time when one person said during that time, the other person said, oh. So we just correct that way.
Or other stimulants during nighttime?
You got me there, Doc. I do drink a lot of coffee.
All right, so now you got the basic idea. So for this nice interactive waveform, we are using a library called wavesurfer.js, and it is really nice. Unfortunately, it has like normal JavaScript mutable API, but obviously it can be worked with. It also has nice plugins. You can see there an image for a plugin for regions, which we are using to represent segments. And how do we isolate ourselves from the mutability? Of course, with a layer of immutability. So on the top of there, you can see we have a map of segments. So from segment ID, we have some segment metadata, start time, end time, etc. We update that after each user interaction, and we have undo vector and redo vector for having undo history. All right, so let's talk about a critical UI challenge we had there. So on the top, you see what we get for free from the library. And this is about representing overlapping speech. So when two people are speaking at the same time, we have to display segments at the same spot. And really the issue was only realizing what is the problem, that the fact that they are semi-transparent doesn't really help. It's not that useful. So after that, it was easy to customize the display with CSS. It's amazing, when I think how it would look like in desktop UI, we would maybe have to request a feature from a vendor and wait a year. But here, on web, you just some CSS and that's done.
But can I have your name, please?
Okay.
Yes, it's George Coffee.
Oh, Mr. Coffee.
So here we have a different problem when something said by a speaker wasn't recognized as said by a different person.
Can I have your name, please?
Yes, it's George Coffee.
Oh, Mr. Coffee.
And what we had to do was just to select the text and click a button. And this is basically an annotation equivalent of the extract function refactoring. And another interesting challenge was local undos. So let's start from the video again. What I'm doing here, I'm selecting segments, deleting them, then undoing that, so they are back. Then I went to the first transcript, updated it, second transcript, updated it, back to the first one, clicked undo. Back to the second, the change for the second is still there. So obviously we have multiple local undo histories, both on the segments level and on the transcription level. And this is good in a way because it allows us to update access the history for the segments independently of each other. But obviously it's not an established UX pattern, so that's a problem there. Plus it's a challenge when we have an action on a segment that has implications on the transcription. So it's also a more complex to implement thing. Another challenge was updating the transcription with keeping the user's changes after the user during the user is resizing it. So we have updated the transcription manually, and then we started resizing it. So the software obviously gets the data from our input data and what were the tokens at that time, and adds it to the segment. But it also has to keep the data entered by the user. So it's basically a merge problem. And the solution is here, and I'm showing it as maybe we have today some people new to the language, so it's nice to show how short, I guess. It can be, obviously, it could be even shorter, but that's what I came out with. So basically, we have two inputs here. One is the user's transcription, what they have updated, and second is what is the original transcription for that segment period by that speaker. And we always prioritize the user's tokens. So we start when the tokens are about the same token from the original ML data, we use the user's token. Second case is when this is a user's insertion, for example, totally manually entered by them. We use that, of course. And the last chance to use the user's data is when we know that we can insert some original tokens, but later on we can use the user's token. So we just let in the original tokens, and we later use the user's token. Failing that, we have to drop the user's token, and the first thing in count is the exit condition. In that case, we just use the remaining original tokens. All right, so I would like to thank a few people: Diane Nichols, Dr. Øystein Andersen, Professor Mark Gales, Dr. Kate Neal, and developers Adrian, Alex, Andrea, Daniel, Dave, Donovan, Jamie, John, Matt, Matthew, Peter, and Yanis. Thank you for your time and attention. Hopefully this has been as enjoyable as working on this has been. I think when the problem domain is human works, it makes coding even more enjoyable. And when you use Clojure for that, it just multiplies the fun. If you have any questions, I'm, during the coffee break, of course, available. All right. Thank you.